Okay, so the last part of example 6, this is the starting point of it. I grabbed the n, which is greater than or equal to 5. I did the base case by putting 5 everywhere. I checked the left-hand side, I checked the right-hand side. Turns out that everything is fine. And I started by writing the inductive hypothesis. And so I'm now ready to do the proof. So again, I'm going to be thinking about this right here, kind of like breaking it down mentally real quick. So it's technically 4k plus 4 plus 1. And so that's really gonna be 4k plus 5. So it kind of looks like what I started with, but with a 5 instead of a 1. So that's something to keep in mind eventually. So here we go. I'm gonna begin my proof. So I'm gonna say something like this. I know that, so I have already assumed that 4k plus 1 is less than 2 to the power of k. So let's go ahead and add 4 to both sides. This is perfectly legit, and by doing that I would end up with 4k plus 1 plus the extra 4 that I'm adding, and it's going to be less than 2 to the power of k and then the extra 4 that I'm adding. So why am I doing this? I'm doing this because now this left-hand side is going to match my want to show statement. It's going to be the same thing as 4 times k plus 1 plus the extra 1. So I factored the 4 from the beginning, from the end, and I leave the 1 out of this. So this is now matching with my want to show statement, but the second side is kind of off. It's supposed to say 2 to the k plus 1. It says 2 to the k plus 4 instead. Well, let's go ahead and fix that. And how can we do that? Well, I can rewrite it as 2 to the power of k plus, instead of 4, 4 is the same thing as 2 squared. So I'm just converting the 4 to 2 squared, no big deal there. And I now need to recall or remember that in general, 2 squared is smaller than 2 to the power of k as long as the k is bigger than or equal to 2. This will technically hold. But in this problem, there's no issues. The k is at least 5. So for sure, this is going to be true, right? There's no question about it. So what does that mean? That means that I can now grab all of this and kind of say something like this. So this inequality can now be considered to be less than 2 to the power of k, so that one stays the same, and the 2 to the power of 2 can be replaced with 2 to the power of k. Since it is less, I can basically replace it. So again, kind of like what we did earlier, we took this guy and replaced him with that guy, so replace. And from this point on, I could just drop the middle term. So the middle term can be dropped, so now we're left with 4k plus 1, and the middle term is gone. Now we have the blue 2k plus the other one, and think of it as one coin and a second coin, so there's 2 coins, so we can now kind of write them together, 2 of the 2 coins, but using exponent rules, this is basically saying that 4k plus 1 is going to be less than 2 to the power of k plus 1. Which is what we wanted. So QED.